Okay, so yeah, it's 12, so time to start. Thanks everyone for joining. This short speech will be about how to design a circuit in the free open source hardware way. Who am I? My name is Dario. I'm Italian, 36 years old. My background is not software related. I'm an electronics engineer. And currently I'm the hardware team lead for Volumio. GNU Linux user since 2002, so quite long time ago, and proudly Ubuntu user since 2016 with release 5.4. The beginning was not my main operating system, but nowadays for my daily personal and work-related stuff, I do use Ubuntu in one of its flavors. So the agenda for today, I'll give a short overview what is required to design a circuit. Very high level explanation, and then I'll tell a bit what free open source software tools I use to design circuits and why I like to use them. Later on, I'll give a bit of tricks for how to design a circuit that can be produced by a PCB manufacturer. So then you can do for your own or for selling them. I will give some example of commercial product designed entirely with free open source tools, and then I'll tell you a bit more about my experience on releasing some hardware design to the community to give bit back to the world. Okay, how to design a circuit. So designing a circuit is not a straight line that you start from one point and you end up in another point, but there are a lot of interaction between all the several steps. Usually you start with an idea or some design specifications. Then you move to design the schematic. For designing a schematic, you need some components to put on your schematic, and you take them from a component database. It might be required that you do some simulations of your circuit or part of your circuit, and then you move when the design is ready, the schematic is ready, you start to do the PCB layout. Also in that case you might require some simulations. When your PCB layout is done, you generate documentation, manufacturing files, and the PCB 3D model. It might happen that you get feedbacks from the manufacturer or from the mechanical engineer that use your PCB 3D model for the enclosure. So you need to go back to the PCB layout. So maybe you need to add other components to your database to put them in the schematic. So it's a bit of back and forth till you have everything ready and everything verified to move forward with production. So this is what I daily use for my work of designing PCBs. My development platform is Ubuntu PC, simple desktop PC running Ubuntu. And for developing hardware, I use KiCad. Explain why in a later slide. I do use FreeCAD for generating the 3D model of the components. LibreOffice to edit the bill of material file and to open the files that usually PCB producers send you back for verification. And I use Git for version control of the component library and of the design files. If the PCB has an MCU on board, microcontroller, I use Eclipse if the firmware has to be written in C or C++. And since a few years, I can program the microcontroller in Python, and for that I use Thorny. It's an open source IDE for Python and works really well with the microcontrollers that do support MicroPython. And again, Git for a version control of the software. Why KiCad? Yeah, first of all, it's free and open source, so that's nice. I do work for a startup company, so spending thousands of euros in licenses, it's nice if we can avoid that. And it's multi-platform. If I need someone else to do the review of my file, I can just send the design file made with KiCad, and whatever operating system they use, they can install KiCad and open the design file. There is a huge user base and community working and using this tool. In fact, every new release gets better and better and better. The file format is differently to the commercial softwares. It's a human-readable text base, so it does work really well with Git. And sometimes to speed things up, I can just open the file with the text editor and manually change some values. And sometimes I do use the search and replace function, and this saves a lot of time because of the file format. It's very handy to also manually edit. It does have a very powerful schematic editor and a very powerful layout editor. I've been using in my career, I think, almost all the commercial software: Cadence, Altium, Mentor Graphics. And with KiCad, I could do everything I could also do with the other commercial softwares. There's nothing I cannot do with KiCad, so that's very, very nice. It does have a very nice symbol editor and the also nice way how to organize the component library. So symbol and footprints. It has an embedded ngSpice circuit simulator. So as I mentioned before, sometimes you need to simulate part of your circuit. You don't need another tool for that. You can just assign the simulation model to your components, and you run the simulation within KiCad. There is a very nice PCB parameters calculator for calculating impedance. If you have differential tracks, for example, you can do everything with it. And then you can export manufacturing file, the Gerber files, in several formats according to what your PCB manufacturers need. And another very nice feature, it has a 3D viewer of your complete board, including the components, and then you can also export the 3D model of your complete board. That's very important because, quite often you want to make an enclosure to fit your circuit inside. And the best way to do first time right is to export the 3D model of your circuit plus all the connectors and components and give this to the mechanical engineer that can import this 3D model in his mechanical CAD tool and verify if everything fits together. Might give you some feedback, so please move this connector a bit to the right, or please change this connector with another one. Everything can be done within the same tool. So start a bit. So this is something that for manufacturing a PCB is the very first step, and usually is the most time consuming one, for me at least, is to create a solid component database. Every component is required to have symbol and a footprint. Symbol is the logical representation of your component that is used inside the schematic. And the footprint is the physical representation of your component. So defines all the paths that then will be on your circuit, and the component will be on top of it, and the pins will be soldered to the copper paths over there. Something that is very important is to have to add some additional information together with the symbol and the footprints. For example, the manufacturing part number, the link to the datasheet. You can also add the reference number to the component, to the vendors, Mauser, DigiKey, whatsoever. It's important to do this in this stage, because then later on you can take all those information to generate the bill of material that will contain all those fields. So this will make less prone to error when you will give those files to the PCB manufacturer, because they will just take what you told them to take. So spending considerable amount of time on this is important. You will save a lot of time in the future if you do this properly. Yeah, the schematic, I think it's quite straightforward. Is the logical representation of your circuit. So how the components, passive and active ones, are connected together in a logical way. And you may add some notes on the schematic for people that have to read it to understand what your circuit does. This is an example of an open source project I released. It's a headphone amplifier made with vacuum tubes. Yeah. Something to note, every component has a specific label, the reference, so C13, C15, R1, R2, and so on. And this is important because from the schematic editor you can export the bill of material, we will see later on, where to any of the components is associated the part number. Next step is the PCB layout. So it's the physical representation of your circuit, and this is what it will be produced by the PCB manufacturer. Before starting laying out, it's very important to set up within the layout tool the design rules. So basically, it's a set of rules that must be taken from the manufacturing capabilities of your PCB manufacturer. So how thick must be the minimum thickness of the track, the minimum distance between two tracks, the minimum hole size for your bias. So before designing, starting with layout is very important to set this properly, and because this will also affect the cost of your circuit. If you relax some of those rules according to the price of the PCB manufacturer can offer you, nowadays you can get very cheap PCB. For example, a simple 2-layer with the most relaxed rule can be produced like 10 pieces for $5. So it's really something that is very affordable, and was not true when I was studying. So it used to be very expensive, but nowadays people can experiment to design their own PCB, having them manufacture and learn. Last step is the manufacturing files. The mandatory one for producing a PCB are the Gerber files, if you want to have the bare PCB. The Gerber files is a list of files that are loaded by the manufacturing machine to be able to produce all the layers of your circuit. So the copper layers, the silkscreen layers, so the little text you have on your PCB for being able to recognize where every component is. You can have the stack-up layer, for example, that tells you the distance between all the layers of your PCB, and those are the required ones for having the bare PCB. If you want to have your circuit assembled also by the PCB manufacturer, you have to provide them the bill of material. That basically is a spreadsheet. You have an example on the top right corner where all the components are associated to some generic parameters. If you want to let the manufacturer pick one component with those parameters for you, or you can also assign a specific part number, so the manufacturer will just buy that component and place on your PCB. It's very important that those files do not have error, otherwise there is a high risk your PCB won't work. And the last one is the pick and place centroid file. So for every component on your circuit, you have the XY coordinate and the rotation. So one of the machines that you use in PCB production will pick every component and place on your PCB on the right location and with the right orientation. So again, those ones you don't need to write on your own. They are generated by the tool if you do the previous steps correctly. And yeah, last but not least, as I mentioned before, generate the 3D model. So this is important if you want to check upfront the mechanical fit with an enclosure. This is an example of a hut for Raspberry Pi, and so you can then get sent to the mechanical engineer or to yourself if you are able to do some mechanical CAD work, the 3D model of your circuit, the 3D model of other pieces of the circuit all together, and then you can create an enclosure that you don't need to do trial and error. Usually it will be, if you take also the right tolerance in consideration, there's high chance that this will be first time right. So a few examples of commercial design, quite complex ones, done with the tools I mentioned before. This is an integrated amplifier with the Volumio operating system running on board with several digital inputs. So as you can see, the PCB is quite big, and it's not only one PCB, it's several PCBs connected to each other. And we managed to do first time right fitting with the chassis because of the capability to export the 3D model of the board. Another example is streamer, so a bit simpler than the one before, but again, first time right fitting with the chassis. And yeah, last part of the talk. Okay, we discussed about free software for generating circuits, but I would like to give a few words on also how to contribute to the open source world, releasing hardware project. When I started to design circuit, I found very useful that people put their own designs on the internet. So I could study them, understand what they did, and learn from them. So now that I became a bit more experienced person, I wanted to give something back. So this is a list of a few picks from this GitHub repository where I shared open source hardware files. Mostly they are simple projects that I do as a some of them are side projects for a bigger one, where, for example, I need a programmer for the microcontroller, and I could not find one that was satisfying me 100%, so I designed my own one. When the work was done, I released it on GitHub, so other people can copy it, modify it, improve it. And the same applies for some others are hobby projects that I like to do in my spare time for giving as a present to friends and family. Yeah. The one over there is a hut for the Raspberry Pi with an OLED display and microphones and push buttons. And I'm particularly attached to it because it was a present for the Volumio community when I joined the community. I wanted to give something to the community, so I designed this as a gift to the community. And again, it's open source. What is available on any of those repositories is the design description. So what this project is about. The schematic, of course, and layout. And if people want to produce it, again, those are simple designs, so they can be produced for very cheap price. There are the Gerber files, the bill of material, and the pick-and-place electronic files. And yeah, in my experience, from time to time I get an email from people from all over the world asking questions about the design, because, hey, I like this project, but why you did this, you selected this, or you made this choice, or how can I'd like to modify it for fitting my needs, and I'm more than happy to reply to those people. Because again, when I was starting this, to gain experience, people helped me. So I'm very happy to help people when they ask for help. That's all, more or less. Thank you for your attention. And yeah, if you have any question, I don't know how much do we have. Yeah, I think we have about 5 minutes. One moment, I'll give you the microphone.
Hi, thank you for your presentation. I have like 2 questions. Like one relates to in the beginning you said the footprint and the symbol. Do you also define the 3D model at that stage?
Yeah, I forgot to mention that.
Because I didn't see like the tube
yes,
coming
yes.
up. The height might be relevant in your amplifier
That's
example.
Correct.
So it also fits.
Let's go back. When you, in the footprint editor, you can attach a reference to the 3D model of the component. So that is taken later on from the layout tool when you can export the complete 3D model. So the board with this shape plus all the 3D models of the components. And this is what you get at the end.
Okay. Yeah, I was missing the tube in that screenshot, but that's a different model, I think.
No, it's a different project.
Yeah, different project. And then for the layouting part, can you set like constraints for auto layouting? Like in your analog example, you might want to have like parallel lines for the inputs.
Okay.
Or like very short lines. Is it,
okay, I personally don't like auto routing. I prefer to do routing on my own. But the CAD tool can help you if you have a differential line, for example, to route 2 tracks with the same length. Okay. But then you need to set up upfront the proper constraints, so the distance between tracks and how thick must be the tracks for having proper impedance of your track. So that's definitely possible within the tool. Cool. It's but you will not have a button do the layout for me. So you need to do on your own. And
usually you start with an auto layout and you start tweaking. Like that's what I usually often do, or like especially for complex
it's a matter
circuits.
of choice. I don't think they have implemented an auto router within KiCad. But maybe you can have something with third-party plugin. The other nice tool about the other nice thing about this tool, if you have a missing feature, you can always write a plugin and use this plugin together with the tool. But yeah, it's a matter of choice. For me, I find it faster to do the layout by hand on my own, rather than having a tool doing the layout for me and then tweaking it, because you might miss something, and if you do step by step, the risk of having something that is not according to what you have, to what you want, it's lower.
Thank you.
Do you get much in the way of contribution from people who look at your projects? Like, do you get traditional pull requests?
I do get quite some forks, and sometimes not a lot of pull requests, to be honest. Mostly they contact me via email, so there is my university email in the GitHub repository, so they write to me to mostly ask questions about the design and how they can modify it, or if something is not clear, why I made some choices in the design file.
Do you think that's because, like, get is a little bit newer to the hardware community than the
That's
software
also another
community?
reason. I think not a lot of hardware designers are very familiar with Git. So they can, in GitHub, you can download the zip file of your complete repository, but pull request, it's something that it's not common to hardware designers.
So the last time I did anything PCB related was 22 years ago, where I was
Okay.
using permanent markers and ferric acid to get everything
I
out.
also
And I had the
did,
model in my head, so I had no
also
computer
started
help.
with that, so I know what you're
Okay.
talking about.
And I'm actually trying to get back into this with my kids, and this looks interesting.
No,
Do you-
it's,
so you have a project with a pre-built schematic, but do you have like some guide or tutorial to actually use the tooling to get to what you're offering?
There are plenty of tutorials on internet. As I said,
Okay.
KiCad has a huge user base, and there are a lot of YouTube videos that can teach you. I could not find ready-made books about how to design a PCB with KiCad, but there is a very nice community, the KiCad community, and there are a lot of YouTube videos that can show you how to do step-by-step, to start from an idea and add up to something like that.
Right. So yeah. So if you have that, like in the form of how to get from nothing to that, even if you offer the whole thing, that would be great too. Just
Yeah,
another
I'm
suggestion,
not
yes.
really good in
Teaching.
teaching.
That's hard.
It's not really my area, and I never posted a YouTube video in my own life. So, but there are a lot of people that do that, and I keep always learning new features from this tool. The more I use it, the more I learn. And sometimes, okay, I would like to do this. I start to search, and I find either a tutorial or a video that show me step by step how to do that.
Can you
So-
put the slide back up with the list of tools that you use?
Yeah.
Thank you.
Quick question. Would you say that KiCad is feature complete, or is there like still innovation on what is being added?
That's a good question, because any new major release, I think, oh, now it's really complete tool. But then for example, this happened to me, the very first, I started with KiCad in 2012, with KiCad like 3 point something, and I could realize it was not a complete tool. But when they released the version 4, it was started to become close to the professional tools. With the release 5, I thought, okay, that's everything I need for designing a circuit. But then they released the version 6 that they could make it even better, adding some more new features to it. So I would say, for me, it's complete now, because I can do everything I want with this tool. But most probably, I will be surprised when the revision 7 will be out, that they will add even more capabilities to the tool. So then I would say again, oh, now it's complete. But being an open source software with a huge community in the background, people request, okay, I'd like to have this feature. And then this is evaluated by the developers. And if more and more people found this useful, maybe they will include this in the new revision. So it's the beauty of open source. Can only get better with time.
Thank you.